We're going to see that here. So this would be a really good place to solve or pause and try to solve the rest of these. I'm going to burn through them here. This is like just a reminder one. We should really know this. If we're doing g plus k of x, and remember it could also be written like this, we can just literally add these functions. So g plus k of x, let's look at g. It's the root of x minus 4 plus 1 over x. Okay, that can't really be simplified down any further. I'm going to leave it there, but I am going to write, comma, my restrictions. X has to be greater than or equal to 4, and x cannot equal 0. Those are two restrictions that are here, coming from here and coming from here. Okay, 2. This one's for sure going to give us restrictions because we are going to get a rational function. So if we look to divide f over k of x, that means I'm going to have f of x on top, 2x plus 1, over k of x, which is 1 over x. Yes, we can simplify this, but I just want to note first, this whole thing can never equal 0. The only way that your denominator could be 0 is if x is 0. So we see a restriction right there. We know that this is going to equal 2x plus 1, and you can think about it being over 1, times the reciprocal, so times x over 1. So this is going to equal x times by 2x plus 1. And we can leave it there. You don't need to take it in. But something to note is that we know that this is only true if x cannot equal 0 because of this. We have to go back to the original function. So not only do you look for restrictions for where you ended, which this doesn't give us any, but you also look at where it started. And you might get points of discontinuity on your graph. So if you were just to graph this, please listen to this, if you were just to graph this in your calculator, it would show a continuous function. Oh, I'm sorry, I'm just talking so much. But there would be a point of discontinuity right there. Okay, my voice is gonna go, so I gotta get through this. And I need my voice for Vegas, people. If I did k of h of g, oh my gosh, I sound like a smoker. Whew, I am not. Okay, if I do this, you have to first start. What is your innermost function? It is g of x. So let me just write that. X minus 4 rooted. I have to put that inside of h of x. Okay, h of x was x squared. So I'm just going to put this around and put x squared. I need to put that inside of k of x. So actually let me just see how well I can run this thing. Let me see if I can move this down. There we go. Look at me go. I'm getting this, guys. This is inside of k of x because k of x was 1 over x. So I put f of x inside of h of x, inside of k of x. And I definitely have some restrictions here. But let's simplify it down first. So that square is going to cancel out my root. I am just going to be left with 1 over x minus 4. Okay, right away, I know x cannot equal 4, right? It cannot equal 4 because that would be 0. But I can actually include that whole idea inside of this domain. If I go back to this root, I know that x had to be greater than or equal to 4 for it to be a proper root. But I know that it cannot equal 4 because that would make my whole denominator 0. So I'm just going to leave it at x has to be greater than 4. Okay, last one. There was a question like this on your last quiz. And one of the errors that was really, really common was that people found the inverse of h and the inverse of f separately. And then they tried to put it together. No. This is saying inverse this whole function. So first thing we need to do is figure out what is h of f before we inverse it. H of f of x. Okay, so I need to put f of x inside h of x. So I have 2x plus 1, and inside h of x just means I have to square it. Okay, next step. Let's go h of f inverse of x. Okay, so this means I flip my y and my x. So it's going to change to x equals 2y plus 1 squared. I'm going to root both sides, so I'll get the positive and negative x equals 2y plus 1. And then I can go, I'm going to move this over, so I would have negative 1 plus or minus, and I'm writing it out front because it just looks cleaner to put those operations in the middle. And now I'm going to divide it by 2. And this would be equal to h of f of x inverse. And I would expect this to be circled so I don't have to hunt for your answer. Are there restrictions here that we should look for? Okay, well, we had a root. We end up taking a root of x, so x actually has to be greater than, oh, my pen's being wonky, greater than or equal to 0. And I don't think there's any other restrictions on this one, but that would be part of your restriction. And it should, this looks really messy, I would like it to look like that. Okay, if you made it through this, if I did it in time of your class, I'm glad. If not, hopefully you guys can kind of watch it at home. I can also share this whole document really quick. Here are some places that you can study inside of your booklet. There are 2 practice tests. I think I've showed you that I never assigned, that we skipped at the end of each major section. Great things to study. I've given you 2 study guides in class. If not more, I will post the keys in the Google Classroom. You have old homework assignments because as great as you all are, I'm pretty sure that you didn't do all of your homework assignments. Maybe you finished some, I hope so. And then if there's a specific concept that you're like, man, I never did get this, go back on the Google Classroom and there's videos for everything. Everything that you need is there. So thank you for listening. If you did, see you next week. Wish me luck in Vegas. Vegas. Woohoo! Okay, bye guys.